Today we're going to integrate e to the x multiplied by the inverse sine of e to the x. So the first thing we'll do is we'll differentiate the inverse sine of e to the x. So if we say u is equal to the inverse sine of e to the x, we can rearrange that and say sine u is equal to e to the x. Differentiating both with respect to x will give us cos u du dx is equal to, on the right hand side, just e to the x again. So now what we can say, du dx is equal to e to the x divided by cos of u. So now we want to replace our cos u. We'll do that by taking this line here, squaring both sides to get that sine squared is equal to e to the 2x, and using the identity that cos squared plus sine squared is equal to 1. We can rearrange that for cos. So cos is equal to 1 minus sine squared, all square rooted. And now if you remember that sine squared is e to the 2x, we can plug this all in here. So we still have our e to the x on the top, but the denominator now is 1 minus sine squared, which is e to the 2x, all square rooted. We've done this because we're going to do by parts. The thing to differentiate we'll have as the inverse sine of e to the x. And we now know then that when we differentiate this thing, we're going to get e to the x divided by the square root of 1 minus e to the 2x. To integrate, we'll have e to the x, and integrating that will give us again e to the x. So sticking this all together, we'll have u times v, the original integrand actually, e to the x, multiplied by the inverse sine of e to the x. Take away u dash v. So our e to the x's here and here will combine to make e to the 2x. So we'll have the integral of e to the 2x over 1 minus e to the 2x, and again square rooted on the bottom. We can actually rewrite this. Instead of having a square root on the bottom, if we write it as 1 minus e to the 2x to the power of negative a half, we can have a look at doing the inverse chain rule. So if we differentiate 1 minus e to the 2x to the positive a half, what we see that we get, our half comes to the front, we get the bracket e to the 2x with the lower power, and we differentiate the bracket, so we get a multiple of minus e to the 2x times 2. These 2's and the half will cancel, and what you can see then is we have exactly the same thing as in here, apart from with this little minus sign. So this integral is actually equal to negative 1 minus e to the 2x to the power of a half. So we can take this all together then. Our integral I is equal to e to the x multiplied by the inverse sine of e to the x. And then the minus here and the minus in there, they'll cancel off. So we're going to add 1 minus e to the 2x to the power of a half. And a plus c, as always.